One of the most important things on electronics, which makers also underestimated, is powering. Now imagine you built an amazing Arduino project and you want to take it off of your desk. So you need correct powering. You have to decide how you're gonna power it. First of all, what's the operating voltage and what you're gonna use to provide that specific voltage. I'm Jenner, and in this video we're gonna talk about correct ways and more reliable ways of powering your circuits. So first of all, for the most boards like Arduino Uno and Nano, the sweet spot for operating voltage is between 7 volts and 12 volts. Any higher will fry your board or will shorten its life. Let's talk about some powering methods. So the first and the easiest method I want to talk about is with a power bank. Now, as you may know, the power banks are usually designed for charging your phones, and your phones work at 5 volts. So it will work with Arduino too. So instead of your computer, you can use power banks. It's regulated and perfect for low power projects that run just a few hours. Now, the most common mistake makers make is an USB port. So they try to power everything with their USB port. For example, let's say we have an Arduino, character LCD display. We have a Wi-Fi module which draws a lot of current. So anything that exceeds 500 milliamps, which is the limit of a USB port. So either you're gonna damage your USB port, or most probably your circuit is not gonna work in proper way. No matter how your circuit is wired good or your components are everything perfect, if your powering is not enough, you're doing nothing. So I recommend power bank just for when you have like quick check up your code or your circuit, and not like using it forever for a project. The second method, and my personal favorite, is the barrel jack. So the barrel jack is basically the jack you see on Arduino Uno. Most newly released boards like ESP32 or smaller boards like Arduino Nano, they don't have a barrel jacket, but anyways, we're going to talk about those on the next minutes of the video. So from a barrel jack, you can power your Arduino with anything between 7 volts and 12 volts. By the way, you can exceed the 12 volts, but it might shorten your board's life. So you can power with 9 volts batteries for quick tests, but they lack capacity and won't last long. But as a solution for this, you can use Li-ion batteries such as 18650 Li-ion batteries, which are rechargeable. Let alone they are rechargeable, they also provide a lot of current. Now, most of them come with low voltages, but you always can regulate these values. I mean, when you drop the current, the voltage increases, and vice versa. So for example, when you put 2 of them together with a serial connection, the voltage doubles. So in this case, one is 3.7 volts and it will be 7.4 volts. And when you do it parallelly, of course, the current increases. So in this case, it becomes 7200. Now, if your project is going to be static, I mean, you're not going to move it and you actually don't need batteries, you can use wall adapters, such as this project I'm working on, a hydroponic lettuce gardening project. So here basically I connected my environment monitor circuit to the socket through a 5-volt adapter. But of course, don't forget to calculate your required current. So for me, I used a 1 amp adapter because I don't have something extra. There's just a display which draws like 25 milliamps at maximum, and a DHT temperature sensor which is like 10 milliamps, and Arduino can draw maximum 200 milliamps. So actually I can use a 500 milliamp adapter as well, but I had this and I used. Now let's say you don't have the output for the barrel jacket, and here you can use the VIN pin. So the VIN pin basically acts as the barrel jacket. It follows the same 7-12 volts rules. But just a quick warning here, there is no polarity, so VIN is positive and ground is negative. If you swap these unintentionally, you're gonna smell that magic smoke. Now, the things we talked so far are most commonly for circuits that don't require too much power. Now let's say we have a 12-volt motor or a high-power LED strip to the project. So basically components that draw too much current for Arduino to handle alone. You need external power. So the motor gets its own 12-volt supply from an external big-ass battery. Let's say you have a 20-volt motor and we want to control it with Arduino. So we will power them separately. We'll wire the motor straight with the power supply and power the Arduino with a different power supply, let's say a battery. So we have two power supplies here, and there's a golden rule here. You must connect the ground of the external power supply back to the Arduino's ground pin so they can talk to each other. But of course you can also use that extra power supply to power both of them. Just put a regulator or an adapter between the power supply and Arduino or whatever the board you're using. If you're working on a desk and building a prototype and can put on a little bit of money, you can buy one of these power supplies. So they provide a precise adjustable voltage and current. This one operates between 0 volts and 15 volts and up to 2 amperes. So this desk power supply is perfect when you're prototyping and still trying to figure out your components' functionalities or your wiring correctness, etc. etc. But a tip from me, always check the voltages and most importantly the current your circuit needs. Because for example, I had a chicken incubator project before and it always kept resetting the motherboard, which I've designed it. And there are actually plenty of mistakes I did there. I didn't put transistors between the relay and Arduino, which is not good for communication between the relay and Arduino, because the solenoid inside of the relay actually accumulates a tiny amount of voltage, and when you cut the power from the Arduino's pin, it can act like a little capacitor, so it sends back a tiny amount of voltage. But yeah, I was talking about the powering. So there are plenty of components, especially on the motherboard. There are 4 relays, LCD display to monitor the cabin's temperature and the humidity. There are relays for the 220 volts motor, the ventilation system, the humidity generator, the fans, and yeah, I mean, the relays can draw too much current. I'm talking from experience, always check how much current your circuit needs. So this is all about this video, guys. I hope it was helpful to you. I've not been posting for like 3 weeks. I went through my exams, so I was too busy with sleepless nights, and an engineering student will understand me. In the next videos, there is a super project upcoming. So if you're not subscribed yet, push that subscribe button and see you in the next video.